Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next episode in the Coding a 2D Game Engine in Java series. So in the last episode, we got our first square up onto the screen. In this episode, what we're going to do is start abstracting some of that stuff away so that we can easily configure this so that we can do a lot of different things with it. This one is specifically about shader abstraction. So what we're going to be doing is creating a shader class and then bringing all of that shader code out into that class so that it does all of it automatically, and all we have to do is specify where the shader is located on our system, and then everything will work out just like it should. So let's code that up real quick and get that nice and clean in our code base. Alright guys, so before we jump into the code, I do want to explain a concept that may be new to you, because one of the things we're going to have to use is something called a regex, a regular expression. Now what these are, they're just glorified pattern matchers that allow you to look for very complex patterns and just sort of do different things with them. And in particular, what we're going to be doing is in our code, remember we have these things where we have like these identifiers, and we basically have like a hashtag type, and then we'll say like fragment, and then everything below this is our fragment shader. Then we have another string that's like hashtag type, and this one says vertex, and then everything below this one is our vertex code. And basically what we want to be able to do is Java gives us this thing called string.split, right? And so this allows you to split a string on, what do we want to split it on? This whole line is what we want to split it on. And so we can use these things called regexes, which allow us to match complex patterns that start with this and end with any text, is basically what we're going to want to say, because we don't know. The user could have a typo and spell fragment or vertex completely wrong, and we wouldn't know that. So how do we use these regexes? Well, in regexes, I'm only going to talk about a few different things that they can do. They can do a lot of different things, but the three main things they can do is the Claney star, which looks like this, which has a very close partner called the plus. I will explain all these in just a second. And then there's also the OR operator, which matches like A or B. And then there is also the range operator, which matches a range of letters. Okay, and so the way you can use this is, say you want to match the letter, any letter, A through Z. What you would do is you would do lowercase a through lowercase c, uppercase A through uppercase C to make sure you match lowercase and uppercase, and then bracket. And what this says is, okay, match anything that is in either of these ranges, except this is only going to find one character. So if your string is like something like A, B, C, D, it will only find this first one. So what you have to say is match, I want to match 0 or more, you would do a star. What this will do is it'll match the whole string up until it hits something that's not in this range. But you could also do something like, I only want to match it if there's one or more characters. And then what that would do is say, okay, I'll match it only if I have at least one character, and then continue going on. So that's what the plus does compared to the star. They're very similar. Then you could expand upon this, say, I also want to match numbers. So then you could do OR 0 through 9. And what this will do is now it'll match any numbers or any characters. And you have to make sure you wrap these in parentheses to make sure that you can have numbers after characters too. And so basically the plus will now act on, okay, I want one or more, any character or any number. And then that's basically the few that we'll sort of be using. And then you can sort of see how we can match something like hashtag type plus fragment. Well, what do we want to do? You can also match straight up strings. So we could say we want to match hashtag type first. We know that's never going to change, right? So it starts with a type. Then we have one or more spaces. So we say plus, we want one or more spaces, at least one space, possibly more. And then we want any letter, any whatever they put, except for new line character. We can't do new line character. And regexes will automatically not check for new line character. So then we can just do our letter catcher, right? A through lowercase z, capital A through capital Z. And we say plus because we need at least one. And so then this pattern will match this whole line, and it will match this whole line, which will allow us to get our two things. And then we can split on this pattern. And what it will give us is it will give us this block of text and this block of text, which is exactly what we want. So that's just sort of a little prefix to what we're going to be doing. We will be using this exact pattern to be able to match those things. So let's jump into the code and actually code this thing up and see how it works. So if you remember, we left off with this giant function that does a lot of different things. But conveniently, we sort of broke it into pieces. So we have compile and link shaders, which goes from here all the way down to here. And so what ideally we would like to do is move all of this code into one shader class. So let's first go into our code, and then we're going to create a new package, and we're going to call this one our render, because this is going to contain all the render related code, which is exactly what a shader is. Then we're going to create a new class, and we'll just call this shader. So the way that I've developed this is when I get a shader, I want it to be really simple. I just want to be able to pass, hey, here's the file path, and then it does everything for me. It's like, okay, now we're going to figure everything out and do all that stuff. And then ideally what we would have is another function, which is compile. And this compiles the shader. So typically these two would happen very quickly one after the other. It is kind of nice to separate them because if you have an error in here, that's going to be different than the compile error. If we just have an error opening the file, we kind of want to know about that before we start trying to compile it. So that's the reason for separating them. And then the last one we want is a couple public void use and public void detach. And if you remember, some of the last things that we did inside of our level editor scene, right down here, we use the program, the shader program, and then we stop using it. So that's why we have all those different things. Now, back into this shader class. One of the things we need, remember, is a shader ID. So what we're going to do up here is we're going to say shader program ID, be a little bit more explicit this time, and this is a integer. And this will allow us to know that we're dealing with a what shader program this specific shader object is dealing with. Now, let's talk about opening up the file and stuff. It's really not that bad, but like I said, it's a little bit obscure how to do the splitting and stuff because of that whole regex thing. So it can get complicated, and I just want to make sure that it does not stay too complicated. Let's go up here real quick. We're going to store a few more strings because we're going to need the vertex source and the fragment source when we go to compile. So we will store those strings up there. And just for error handling and stuff, we will also store the file path. That way we can tell, hey, we had an error in this specific shader if we ever need to. So we'll start off, we'll say this dot file path equals the file path they passed. And then we're going to do a try catch because in Java, every time you try to open a file, you need to make sure you're catching for an IO exception. And while we're on the topic of trying and catching things, I told you that I would talk about how to enable assertions. It's actually pretty simple. If you just go up to run, and then you want to go to edit run configurations. Oh, right here, edit configurations. And then inside of here, under VM options, you want to pass in a -EA. And what this does is it tells Java, hey, when you're running this, just make sure that you pass in that assertion. We want to allow assertions. And then down here, I think this is the OK. And then just press that. I can't see it because it's getting cut off. But yeah, so that will enable assertions now so that we can actually use these. And right down here, if we do get an IO exception, which we will call E, then we'll say e.print stack trace. And then we'll say assert false. And we'll say error could not open file for shader. And then we'll pass in the file path. So that way they just get a nice little error too when that does happen, and plus there. And it says we are never throwing a IO exception. So let's get to that point. How do we open up that file and do all that? So opening up the file is actually the easiest part. We'll just say string source equals a new string, and then you can do files.readAllBytes paths.get file path. And in Java, there's a million different ways to open files. I don't know if any of them are optimum. We don't have to worry too much about whether this is optimized or not because shaders are typically a loading phase type thing, so it's okay if it's a little bit slow. Didn't prove any errors when I was loading things. There's no lag time or anything from this. So this is perfectly fine. And this was just the easiest way I could find to get the string source directly into our string from the file. So simplest way doing this. Next, what we're going to do is we're going to split the string. So we'll say string split string equals, and remember, we want to split on that complicated regex. So what we do is we type in the parentheses for hashtag type. And then we want to say we want to match any spaces, one or more spaces we need. And then we want to match A through Z, capital A through capital Z, and we want one or more of those. And then it will match all that up until the end of the line, which is perfect, which is what we want. So next thing we need to do is, if we go to our shader file, what we have is we have this hashtag type vertex. Now what we want to do is we want to find out, okay, where is the end of this line? And the reason we want to find the end of this line is because we need to find out where this to this is, so that we can find out exactly what they typed in right here. And then we'll need to do the same thing down here and find out exactly where they typed this, so that we can see whether they typed fragment or vertex. I said those backwards, but you get what I'm saying. We basically need to find out, okay, where's the end of hashtag type and where's the end of this line? Then we're going to take whatever word was written there. And to do that, we do a little bit of some jujitsu to get to the end of the line. So we'll say int index equals source.index of hashtag type. And what this does, whoops, two parentheses, we just need one, hashtag type. What this does is it finds the first index of where this is. So it'll return 0 in this case, because right now in the file, we're looking from the beginning of the file. Oh, well, the first time this appears is at index 0. So then we want to add in, let's see, 1, 2, 3, 4, 5, 6 to make sure we get past the word. So let's go back into here in our shader, and we're going to say plus 6. And what this represents is the index that is the beginning of that next word, right? So we know that fragment or vertex will come immediately after this index. So then we need to find the end of the line. So we'll say EOL equals source.index of, and we're looking for a /r/n. If you're on Mac or Linux, you'd be looking just for /n. And then we want to look from the beginning, starting from index. So this makes sure we're looking from wherever this one is to the end of the line after where we found this token. And so then it will take us to the end of the line, which, if we go back to our shader, is right at this position. So now if we take the string between these two positions, what do we get? We get that vertex. So let's go back into shader. And what we want to do now is say string first pattern, because we don't know what it is yet. We can't say vertex or fragment. It could be anything. Is source.substring. And we want to go from index to the end of the line. And we want to trim it, which means just take off all the white space and stuff. And this is going to say the result of trim is ignored. No, it's not. There we go. So if you look at this, it just trims, takes off any white space or anything that was attached to that. Next, we're going to do the same thing except for the next one. So next we say index equals source.index of. We want to find another hashtag type, except we want to start from the end of the first line. That way we don't start from the beginning of the file. If we're starting from here, the next hashtag type should be right here. And then that'll give us this index, which we can then use to do the same thing to get whatever this token is. So then we'll go down here. We'll say end of line equals source.index of. We want to do /r/n from our index, because now that's been moved. And also make sure you do plus 6 here as well. Then we can say string second pattern, so this is like vertex or fragment, equals source.substring from index to end of line dot trim once again. And we can add a comment here, find the first pattern after hash type pattern. And then we will do this and comment down here just so that we know in the future what we're doing here. Find the second type pattern. So then we can say if first pattern dot equals vertex, then we want to say vertex source equals split string 1. And the way that the string will split is we will get some garbage for the 0th index, and then the first index will contain all of this, and the second index will contain all of this inside of that array. So then we can say else if first pattern dot equals fragment, then we want to say fragment source equals split string 1. So whichever they put first is what we're going to put into that split string, and then or into like the fragment or vertex source. Otherwise we'll just say throw new IO exception. If they typed in gibberish, like maybe there was a misspelling or something, unexpected token plus first pattern plus in and we'll say plus file path. Plus, there we go. And so what this will do is it'll go down to our catch block and then throw that error, and it'll basically, actually we could probably just remove this and just leave it as unexpected token because we already say the file path inside of that catch. So we'll just throw an exception if they misspelled whatever that token was supposed to be. Then down here we will do the same thing. Let's just copy this actually, except for the second pattern, and store that one into the appropriate place. So we'll say second pattern and second pattern, and we do the same exact thing, and we just want to pass second pattern down there and take out that semicolon real quick. Okay, and so now this should successfully store the first and second patterns into our vertex and fragment source. So let's print that out real quick just to make sure we did everything. We'll say print line vertex source system.out.println fragment source, and then let's go into our window scene or our level editor scene, and right up here at the top of init, or just in the constructor is fine too, we'll say shader test shader equals new shader, and we're going to pass it that file path, which is assets/shaders/default.glsl, I believe. We'll see if that's right. And then import that from our render. Let's run this and we should see it printing out. Okay, expected semicolon right there. Whoops. Let's see. So we get that. And okay, here we go. So if you look, it looks like we did get a vertex and we got our fragment. So that seems to be working perfectly fine. We got that part up. Now let's get the next part, which is compiling the shader. Let's move this into here too, because this is where we eventually want it all to be. So back into our shader, we basically want that compile function. Well, that's actually really easy. If we go into our level editor scene, compile and link shaders. First compile, okay, check for errors, compile, check for, oh, okay, so we just go up to here. Copy all this, and then we want to paste it right into here. And hit OK, and that will import all the things that you need to import. Then right up here, let's just create a few variables: int vertex ID, int and fragment ID. And there we go. And then let's change this from vertex shader source to vertex source. What do we call this? Vertex source. And let's change this from fragment shader source to fragment source. And there we go, that's the compilation. And while we're at it, let's add in the linking to the compilation because those two are very close together. We should probably link and compile at the same time. So let's go down here. You could change the function name to compile and link if you want to be really, you know, a stickler about that, just so that you know exactly what's happening. And then change that shader program ID, copy and paste it everywhere where you see this. And now we have compilation done. Well, that was easy because we already did all the work. And then one more thing we can do is instead of just saying error default.glsl, what we'll do here is we'll say two parentheses and we'll put plus file path. That way we get the actual shader we were working with, and then do the same thing down here. And we'll say plus file path. And then I think there's one more, yep, down here. And we'll say plus file path. That way we know exactly which shader there was a problem with. And these assertions will now work since we enabled them. Okay, cool. So that's compilation done. And then we go back into level editor scene. Well, we need a couple more things. Let's copy this comment too and just put it back in there with that shader, just so that we have a little box comment telling us what's happening up there. So compile and link shaders. That way we know it's doing two things. And how do we use the shader? Well, we just say GL use program shader program. So copy that. We will paste that into here. And we'll just say shader program ID. How do we detach? Well, we just say GL use program 0, which we could see in our level editor scene too. Okay, so that's all the functions we needed. Now we can compile shaders, we can link them, and we can use them and detach them. Let's test it, see if it's working all right. We will go into here, and instead of saying like all this stuff, we'll say private shader, default shader. And then right here, we'll say this is the default shader. And then we will say default shader.compile. And then down here, we will say, instead of use program this, we'll say default shader.use. And right here, we'll say default shader.detach. And this should work exactly the same. And we got an error. Okay, so what's this error? It says shader compilation failed. Layout location requires... Oh, and that makes sense. So if we go back up to our shader file inside of the constructor, notice how we said this is split string 1 and we copied it. We never changed this to 2, which is the second block of text, which is what we wanted. So if we run this now, there we go. We should get exactly what we were expecting. And it worked just right. And then this is really nice because now if we ever have an error, as you just saw, it will print it out and break out of that thing to let us know. So if we forget a semicolon or something simple like that, it breaks out and it says error in default.glsl. And if we go up here, it says syntax error, unexpected reserved word, blah, blah, blah. And we can be like, oh, we missed a semicolon. Fix that real quick, run it, and now it works fine. And then we can also create new shaders and use them just as easily. So this has been our abstraction of shaders. Didn't really go over how they work still. I'm going to wait for that for a future tutorial when it makes sense, when we're actually be changing some things in them and we need to know exactly what they're doing. So next tutorial, what we're probably going to be doing is possibly talking about starting to abstract this stuff out. This is a large project because this entails a batcher. We're not simply going to abstract out like we did with the shader. It's actually going to be a little bit more of a project, but I think we're at a point where we could start doing it. So next tutorial is probably going to be talking about what a batcher is, how we can use it, and then we will start implementing it in the tutorial after that. And that's about it for this tutorial. We can delete this stuff too. I hope you guys liked it. If you did, please hit like and subscribe, and I will see you in the next one. Thanks. See you.